It'll be a bit disappointing compared with Richard and North Sea last night. I'm going to try to give a quick talk about Instant JChem. Ian's done quite a lot for me already. So Peter's going to help me with do some demos while I talk so we can speed things up a bit. So first, let's acknowledge the people involved. The people from the IJC team on the described on the left. The people with asterisks beside them are people who are hopefully here, so you can go and hunt them out and talk to them. People on the right, there's a large number of people from ChemAxon who have contributed to this. Far too many to name, but I've tried to name some of the key people here. Apologies to the many others who've contributed who I haven't named there. Also, bottom left corner, a couple of people have also contributed to some of the content of this material. James Ilston, who's an ex-colleague of mine in the UK, who's helped with one of the case studies, and Tim Miller, who's helped with some of the Markush data that we're going to look at. So I'm going to basically cover three things. What is IJC? Very quickly, in case you're not familiar with it. We're going to very briefly cover what's new since last year's UGM. Again, I'm going to cover that very quickly. And most of the time, I'm going to try to concentrate on three case studies of how IJC can be used as a tool to deploy databases to your users. Okay. So what is IJC? IJC is designed to be a tool for you to give to your chemists and your biologists, and it's supposed to be something that's easy enough for them to use. And from what Ian says, that seems to be the case. The idea is that you can design forms and things like that, have a good way of viewing your data, but also provide some very comprehensive and powerful chemistry search features and things like that. So the question is, how do you create data like that? How do you create a form? How do you get data in? So Peter's going to do a demo here of what I really call classic mode of IJC. This is how it was originally envisaged and probably how most people use it. What he's doing, he's importing an SD file. This is a Maybridge screening compound database that's available as an SD file. He's running through the import wizard, choosing default options for everything. The import happens. This is a file of about 50 or 60,000 compounds. It would import in about 3 minutes or so. We're not going to wait. We'll just cancel at the current stage. And IJC has now imported that file into a database table. It's created all the paraphernalia that IJC needs to display it in what we call the grid view, which is the spreadsheet type view. That you're seeing. That's all been created for you automatically. And now Peter's going to go on and start running some searches. So he goes to query mode. He's got a query that was already there. So he's going to search that database for pyridine. Runs the search. He gets the results back. They're highlighted and lined as he drew them. He's now selecting a few rows in the database. And he's wanting to create a list of those rows so we can start working with those rows. Give the list a name called test. And now he's going to go to the lists and queries window, and we see two lists there. One was the one he just created manually, and the other is the result of the query he just ran. And what he's going to do now is he's making that list permanent so that it's still there if he closed Instant JChem and bring it back. He's renaming it, giving it a more sensible name than the automatically generated name. And now, once he's got this list, he's going to use a new feature that's in this latest version that is just about to be released, where we now support lists of multiple fields. So any field that is an integer or a text field, we now support lists for. And so what he's done is converted it to a list for the code field. And if you look at that in the grid view, that's the code that Maybridge gave to that compound. Now, in previous versions, we could only handle the primary key values as lists. Now in this version, we can manage lists from any field. And as you see, what he's done now is he's converted that list to the list of the query results from the CDID field to the code field. So we've now got a list of those codes. And then we can work with those lists, and we can work with the real suppliers' IDs, not our own meaningless internal IDs. So this ability to in this case, to drag and drop the list from one field type to another, we automatically convert the values between the fields and things like that. This lets you do some really quite clever things with your lists of compounds. Okay, So that's a very quick demo of what the sort of things that IJC can do. So that has hopefully described what Instant JChem is. I said it's aimed at biologists and chemists, not IT people, though I'm sure IT people will enjoy it as well. The main emphasis is chemical search and reporting, and it's a database-centric application. You can create local or shared databases. So what's new since last year's UGM? Well, there are a number of things. The most, probably the biggest areas is support for new database features. There are a lot of new things we've done in this new version that will be hitting the streets very soon. The key ones, actually some of these are in older versions that are already released, but this first feature, the support for multiple Oracle schemas, is something that has been requested by a number of customers. This means you can now use tables from any of your Oracle schemas as long as you've granted the appropriate privileges to access those tables. This increases the flexibility of using IJC in an Oracle environment quite significantly. We also added in the previous version support for text-based primary keys, whereas before that we only had integer primary key support. We've got support for database views, and as you saw from Ian, that is already being useful to Evotech at least. We've got improved support for JChem cartridge, and we've got a significantly improved schema editor in terms of usability and the functionality. And we've added a few extra security options. The second main area is what we call URL fields. This is the ability to link in and link out to data that's on your network or on the internet. The screenshot on the right shows you an NMR spectrum that's been pulled in from a file that's on your disk. Ian was doing the same sort of thing in some of his screenshots. We can similarly link out. So you can generate a URL, click on it, and it opens a document on the internet or on your file server or anything like that. So we can link out to places like ChemSpider and PubChem and things like that, using URLs that can either be dynamically generated based on the content of other fields in the database, or can be a static URL, meaning one you've just typed in the full path for the URL. And this provides you a lot of nice ability to link in and link out to data that isn't within the central IJC database. List management improvements, which Peter demonstrated just a minute or two ago. This is quite a significant improvement if you're using the list management features. And a number of miscellaneous improvements. The printing has been improved quite significantly. We've now got integration for Reactor, which I think Jury showed, he said he showed yesterday. So you can do reaction-based enumeration inside an Instant JChem database. We've got support for additional similarity search metrics, so things like Tversky and DICE metrics and things like that. Generally improved look and feel. The structure render is now a bit more flexible. It can render multiple structures. It can render structures from multiple columns in the table and things like that. And finally, the import of Markush dark files. So what's coming? Well, more database features. This is what we continue to get asked for more than anything else. And yet more database features, and yet more, and yet more. I'm sure this will be, even in Instant JChem 337, will still be being asked for new database features. IJC Server is something we've been working on for a while. I'm not going to talk about it at the moment. It's still in development. If you're interested in IJC Server, just rest assured the development is still going on that, and it will happen. Visualization, as requested by Ian, we're going to be adding things like charting and graphing support and conditional formatting and things like that. That's on the plans for the short term. And calculations as well. The visualization and the calculations are probably our two most requested features, and we're pretty determined to get those done this year. And finally, another module that some of the ChemAxon people here have been working on is a training module for things like logP and pKa. That should be hitting the streets reasonably soon. So I'm now going to move on to some case studies. And the three I'm going to describe. Really, what I'm going to really describe is the situation where, well, let let me move on. There are three studies. One, reporting data from an activity-based database. Secondly, a suppliers database. And thirdly, a description of how we generated the pattern data that Tim was showing earlier today. So the situation is basically, this is what I call the classic or the standard usage, which Peter demonstrated earlier. Import the SD file, and everything is done inside IJC. IJC is good at doing all of these sorts of things. It's a great tool for serving up this sort of data. But there are some limitations. There's a problem, really, that data is infinitely flexible, infinitely variable. But unfortunately, our import is not infinitely flexible. So we cannot cope with every sort of data there is in the universe. It's inevitable we can't cope with all sorts of data. And so there's going to be some data we can't import. Also, similarly, the Instant JChem data model is not going to be infinitely flexible. And we're going to have to do sometimes some data processing to be able to convert the data into a form that can be represented by IJC. And probably another important limitation is that the IJC process that we saw is designed to be run by the user. It's not designed to be automated. So if you need to do things on a routine basis, then there's no real way of doing that in IJC at the moment. Now, of course, we recognize these as limitations, and we're going to be working on removing them, and we'll be seeing improvements over time in each of these areas. But what do you do now? What if you want to use IJC to distribute data now, and you've got any of these problems? So that's what these case studies are going to look into, and try to give you some ideas of how you can work around these problems and use IJC for some more complex types of data. So this is really the paradigm for this non-standard usage. The scenario where you run into the buffers, the standard Instant JChem import mechanism isn't up to what you want to do. What can you do? Well, what you do is actually you move the import outside Instant JChem and do it externally. The rest, the building the forms and the running the searches, you can do inside Instant JChem. That's what it's really good at. So once you've got the data in there, your users should be enjoying the experience of actually running the searches and doing what they want to do. But your problem is you can't get the data in the first place. So what we want to do is do the data processing external to IJC. And what lets us do that is the fact that IJC uses a standard SQL database. And that applies even if you're using a local database. The local database is a Derby database. It's a fully compliant SQL database. There's nothing special about it. There's nothing magical. There's nothing hidden. So you can access that database just like you can any other database. And so you can load data in using SQL, using the JChem APIs, using whatever mechanism you want. And this allows you to much more flexibility in how you can try to get that data in, and it allows things like automation. So what sort of approaches might you want to take? Well, you might load the data straight in using SQL if it's already in the database, let's say different tables. Using things like Pipeline Pilot and KNIME is a very compelling possibility as well. We did some studies a long time ago just to prove that was possible with Pipeline Pilot, and I'm sure it's equally possible with KNIME and the other workflow tools. And you can just write your own scripts and programs, and there's nothing to stop you just putting data in through any mechanism that is compatible with loading data into a database using SQL and the JChem API. And then once that data is in the database, it can be used by IJC as if it had been imported by IJC. So the first case study is a company that we worked with that had data in activity-base, lots of biological data. So they had activity-based biology data and a chemistry database with their structures, and they had big problems in accessing that data. It was in the database, but they just couldn't report it, and they were just unsure about what their active compounds were and things like that. And so, being a small biotech company, they needed a relatively lightweight and simple solution. And so, this is the solution we put together for them. Starting on the left, they're starting with the activity-based database and the compound database. And that information was extracted using some Oracle materialized views into what we term the IJC data mart. So as part of this extraction process, there's a lot of transformation of the data. The data was being heavily pivoted and things like that in order to make it more amenable for reporting. And then once the data was in the data mart, some summary views were generated as well to generate averages and things like that. So you could see the average IC50 where it had been tested multiple times. And in that data mart, we then added JChem cartridge indexes onto the structure tables, which then let us search them in a sensible way. So then once that data was put in using the materialized views, we could then generate the IJC forms to report the data. And what they used, many of the sort of the more expert people used the IJC forms and the IJC functionality directly, but they also just exported the data out using IJC to an Excel file and then distributed that on to their other scientists or their collaborators. So what let us really achieve this was the Oracle materialized views. And what that let us do was to transform the data from the highly normalized data model that was present in ActivityBase into a form that was much better suited for reporting, such as it had the average data already generated and things like that, and the data was already pivoted. And what this let us do was provide very fast access to the data in the right form. As I said, generate summaries. And the JChem cartridge indexes can be added to the Oracle materialized views just to make them searchable in a structurally sensible manner. And then the materialized views are refreshed as required, typically every night or more often if needed. So the snapshot was updated and you saw the latest data. So that's the first example. Second case study is a sort of hypothetical suppliers database. We've seen a few of these, but this is sort of how we could do it in IJC. We've got a series of SD files we've got from suppliers, and we want to import them into IJC. But this import process is actually a bit more complex than just importing it into a single table, because we want to be able to work out which compounds are available from multiple suppliers. So we've got we want unique structures, but we want a record of which supplier it is available from. And we also want to add a bit of smart chemistry here. We want to do things like calculate log Ps, and in this particular case, we're going to generate some Bemis-Merco scaffolds, so we could, potentially we could start doing things like scaffold hopping and those sort of things. We're generating a slightly more chemistry-savvy system. So how we achieved that was by generating some custom scripts that load the data in, and wrote some Groovy scripts for that. I said yesterday I think you might hear more about Groovy in the future. Well, I was right. Here we are. I think Groovy is ideal for this sort of thing, for lightweight scripting opportunities, for sort of things you want to do quickly, get done, and then forget about. It's an ideal opportunity for that. So we've got what we call a Groovy JChem library that actually wraps up some of the Marvin and JChem functionality and makes it a bit more accessible, a bit easier to use. And basically what this does is wrap up some of the SD file parsing, which if you're using the M record reader, it's a bit cumbersome to use, but when wrapped up in the Groovy library, it's very easy to use. Also, we can access the JChem functions such as update handler and those sort of things. It just makes it easier to use. Doesn't do anything new, it just makes it easier. So each SD file has a simple configuration script that lets it be loaded in using the core loader. And the other key thing is some of the Groovy SQL functions really make loading the data into the database really very, very easy. And so we generated a process which is basically run by these scripts that basically creates the tables, parses the SD files, calculates the Bemis-Merco scaffolds, loads all that data into 4 main data tables, and there's one view generated as well. And all of that is really done in less than 200 lines of code in the core loader class, plus a little bit of extra stuff, a script for each configuration script for each file sort of thing. And so here's just a small sample of the code. You probably can't read it, but with very little code, you can generate this import process. And I'll switch over and let Peter demo this quickly. This is a screenshot. We're going to see this live in a sec. So he's just now going to switch to a different project that now has this data in. And so this is the form that we generated. Basically, you've got a structure here. We've got lots of properties we calculated using chemical terms expressions, which are down here in the middle. Down the bottom here, we've got the BMS Merco scaffold that is calculated from each structure, and this is a many-to-one relationship. So the same scaffold, multiple structures will have the same scaffold. So again, we can hop between different structures containing the same scaffold. And here over on the right are the suppliers who supply this particular compound. Now, generally, with those loads of scripts, it was relatively simple to build this sort of database. Okay, so let's switch back to the presentation. We're almost finished. The final example is the Markush demo set, which we saw earlier today. Now, how do we generate that? Well, the situation was we had the content from Thomson Reuters, which was the VMN files containing the Markush structures, and the patent information was present in some fairly complex and fairly scary XML files. In addition, there is some other content as well that we're not actually using yet, but we probably will in the future. IJC was obviously going to be an ideal tool for searching this data and reporting it, but we couldn't get the data in because it's just too complex. As I said, infinitely variable data. We just can't cope with all sorts. So we had to work out a way to get the data into the database. And as always, we needed a solution quickly because we needed to get this out to customers. We couldn't, we couldn't have a long, complex solution. We had to do it quickly. So this is what the data looked like. There's a whole series of VMN files that's in a set of directories that, which is sort of encoded with some magical numbers and things. And we've got a whole series of XML files, and there's a correspondence between the XML files and the structures that's sort of hidden within that data. So the VMN files can be imported into Instant JChem using the standard IJC import mechanism. We've got a way to trawl through a directory, find all the VMN files, convert them to a Marvin file, which can then be imported in using the standard import mechanism. So the structure side of it, IJC could cope with, but the XML side of things, it couldn't. This is a small part of the XML file. And as I said, it's pretty complex. What we had to do is extract out various bits of this XML file and load it into the Instant JChem database. Okay? So basically, we imported the VMN files using the standard IJC stuff, and we loaded the XML files into additional database tables, again using a Groovy script. And then once the two lots were loaded in, the two sets were joined together. In the future, there are lots of extra things we could do, such as providing access to the extra information, such as the images or maybe the actual pattern PDFs and things like that. And then with that data loaded into Instant JChem, we could just zip up the Instant JChem project and then send it out to any customer who wanted to use it. Okay? And so basically, the script in this case creates the tables, it trawls through the XML files, it parses the XML, extracts the data out, and loads it into the database. And again, all of that is done in less than 200 lines of code. Okay? And we generate the database that we saw earlier here. I don't think we'll demo it because we're up to time, yes? Yeah, okay, so let's stop here. But basically what we've got here is an Instant JChem database. It's a master detail form. Basically, we've got, at the master level, we've got the invention that contains all of this patent information that's been extracted from the XML files. And the detail is a structure table that contains the structures that are found, the Markush structures that are found in that particular invention. Okay, and okay, and finally, yeah, that's fine. Okay, so that's it. In conclusion, Instant JChem, with its database features and forms and search, is a great way for serving up data. But sometimes you may be scratching your head and say, how do I get my data into that database? Because the data isn't the right shape to go in through the front door, as it were. So sometimes, well, if your data won't go in through the front door, put it in through the back door. Custom processes can easily be used for this. NIME, pipeline pilot, whatever. There are plenty of ways you can do it. So if your data can't go through the front door, put it in through the back door. Basically what happens here, you let the administrator do the hard work, and you can then still serve up your data to your users and let them use all the standard IJC features to actually search the databases once you've prepared them. Okay, so that's it. Thank you for listening.